All right, so this is two variable data number 5, better known as stats number 5. There we go, stats number 5, two variable data. The title of this one is linear regression. What do you think of when you hear the word linear? Yeah, say it. What's on your mind? What do you think of when you hear the word linear? A couple of you said it. Okay, some of you are motioning. Nice. A line, right? You even see it in there. Just cover up that R, right? A-R. Line. Line E-R, right? If I just say it wrong, it's got the word line in it, right? So linear means something like a line or something to do with a line, right? Regression is a complicated word, and I'm not sure I can explain that in the context of stats. So maybe I won't try, but you'll see what linear regression is, and what we talk about in part of math and the challenge of math is the words don't always make sense to us in a language context, right? Well, so let's see what we've got. Given data that approximates a line, how can we fit a line to the data accurately? I'll show you a little bit more about what that means. And linear regression is the process of accurately applying a line to a group of data or data set. So let's take a set of two variable data. What does two variable mean? It means that here's one of the variables represented by the x-axis, right? Always horizontal axis in math, always an x for our purposes, right? Just say it always is. Vertical axis, going to be a y, right? But we're going to label it with data that has two variables to it, right? So we're going to put study time. Okay, come on. Study time on this variable. So this variable, as it progresses, study time, let's say it starts at 0. I don't study at all. But now I study more. I study a lot more, right? And so that's time being the factor or that variable, right? And it's measuring study time, okay? And so then over here we have grades, right? Grades being low, an F, right? A D, a C, a B, an A, something like that, okay? And we don't even have to put it in there. You kind of get the idea. Higher, better grades. Out that way, more time spent studying. Fair enough? So two variables going on, and you're probably running a study in your mind. You're trying to confirm, does studying more result in better grades, right? And I know that sometimes you're thinking, the answer's obvious, right? Oh, that's an obvious question. But that's always a little bit dangerous in the human realm because a lot of things are obvious or intuitive. And then when we look into them more, it's not true. They're not obvious. They're a lot more complicated than we find out, right? Even just think of the problems with this study, right? What does study time mean? Do I study with my earphones on, right? With loud music? Maybe I study better that way, right? Maybe that's better for me to study. So maybe that's more productive. But another student maybe is in a completely quiet environment, right? So as you see, we start to ask questions about what does study time mean? It starts to get a lot more complicated. And that's the way the human existence is, right? The more we look at the issue, the more complicated it becomes, right? So
Hello, do you have an Andres?
You have an Andres? Yeah, right here. Okay, so you see what we're getting into here, right? The more we start to ask questions about it, and the more we start to think about it, and the more then we can start to argue about all kinds of subtleties, right? And that's the great thing about human existence, I think, is, and we call those nuances. A nuance is a shade of difference, right? What is the difference between, you know, in some families, when they go home to the home environment, there's a kitchen table, and it's clear, and the children are sitting at the kitchen table doing their studying, right? that's a pretty productive environment for study time, right? I can tell you quite the opposite, and even my kids, they don't do that at home, and I'm a teacher. Both my wife and I are teachers, right? They study on their own time, kind of in their own places, in their own way, and we don't regulate that a lot. My first 2 kids we did, and that kind of didn't work, and the second 2 kids we do a lot less of, and they just sort of handle it on their own, right? So for us, that's working out for our family. All families are different. All home situations are different. Many home situations are very difficult to get a place to study. And so what study time looks like, right, across the board starts to get really complicated. All right, grades too, right? This can be sorted and cut back and forth many different ways. So as you're designing your study, you're trying to wrestle with what are all those variables? How does it affect the outcome of the data? Does it make all the data bogus? Right? Does it look like it says something? And in the end, we can find some reasons why that's not what it really says, right? So all of this seems very straightforward at first, and then starts to get really complicated as we think of it more. But let's stay on superficial. Let's go back to superficial a little bit, right? And let's look at the data. Let's say that this is a data point, right? That's one student, that's how much time they spent, that's what grades they got, right? Let's say there's other data here. This is another student, 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 another student. We always want to include, and what you're doing is, you know, this student studied this much time and they got this much grade. Plot a point, right? Each one is an individual human studying so much time and getting what grade, and that point gets put in there. And these are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, you know, number of students, right? At our school, there's 1,400 students. Maybe we could have 1,400 points up there, right? And it starts to look like a cloud, like maybe a bee, a swarm of bees or something, right? But we see some sort of progression there. We see some sort of pattern. Oh, let's put our outlier. You know, here's an outlier, right? Something went wrong. This student didn't study much at all, and they got a really high grade. You with me? Hey, it happens, and you know it does, right? And sometimes it happens for you. Sometimes you have classes where you're like, I study almost none in there, and I have an A. Fair, right? So whatever. But let's say most of the data starts to hit like this. So what is linear regression? Linear regression is the idea that we're trying to accurately fit a line to this data. And in this class and in these introductory lessons, we're not going to do any actual examples. We're just going to deal with the concept of somewhere buried in this mass of data is a line. And we looked at other prior distributions where we had normal distribution. Remember the normal? Right? So that's different. Now the data is making a line. Right? So now we need this idea of linear regression. Where does the line fit? So this lesson literally kind of goes down a course like this. It says, does this line here fit the data? Does this line fit the data? No. And as I put more lines, you're gonna see more. If you're not seeing it yet, you're gonna see more. Well, that one doesn't. Does this line fit the data? Better than that one, right? It's a better fit. Okay, how about this line? Does this line fit the data? Better than this one, but not much better than that one, right? And you kind of see where I'm headed here. Let's say the line is here, right? Somewhere right in here, right? This one, you know, I think it gave us in the notes, it said A, this was line A, this was line B, this was line C, and this was line D, as in dog, right? And it said, which is the best fit line, right? And it's being overly obvious in the beginning. This is an introductory lesson, but the idea of there's a line within this data that fits best. Now you can imagine the complexity of trying to figure out for this data point and this line, there's a distance between them. And for this one, there's a distance, and for this one, there's a distance. And in fact, for every single data point, there's a distance between the point and the line. And so linear regression is the process of mathematically going through a series of repeated calculations to balance out this distance and figure out where that line is. And now that we have a line that's running through the data, we can go back to another topic in math, which fits algebra, right? Remember the idea of slope. Anybody remember the definition of slope? How about the definition of slope? Because we have a line now. Rise over run. That is a definition. Rise over run. Over being a fraction bar there, right? Rise over run. Anybody know another definition of slope? Good. I like where you're headed with that. Y equals mx plus b. What this actually is an equation with the slope embedded in it. And this forms the equation of that line. So slope is a component or piece within that all famous slope-intercept equation. Okay, so perfect. I appreciate that you guys are pulling that up from your data banks, right? There's a lot of definitions. You can say change in y over change in x, like that. Delta means change in. You can say y2 minus y1 over x2 minus x1. Again, a meaning of the change in, take the higher value of y and subtract out of it the lower. So the change in the vertical, which is rise, over the change in the run here, which is run, right? So different ways to look at slope. A lot of sort of different definitions or ways to represent the definition. Okay. But imagine now that you go up your rise and your run, and now I have an idea of the slope and being able to calculate the equation of the best fit line. Now I can possibly predict. Once I have this line, now I can go back the other direction. So let's say this is 5 hours here, right? And students that go at 5 hours of studying, and again, go back to the complexity. Is this per week or per day or per, what does 5 hours mean? Let's just say 5 hours. These students got B pluses, right? Now I can say to you, because now I have the data, now I have the line, now I have the slope, now I have the equation of the line, and now you can tell me what grade you want. What grade do you want, Bridget? Be brave. What do you want? Give me a gesture with your hands. What grade? Right? I want the A. Okay. And it's not always that way. I rolled into plenty of classes in college or wherever where I said, man, this class is hard. It's not worth the time to me. I'll take the C, right? You're always making that judgment. And I think that's absolutely, you're right as a student to figure out where you stand, right? And so if you want the A, well, right here to get to the A, you need to study 5.5 hours. Now I can use the best fit line to instruct. And that's for the average student, right? So maybe it works for you, maybe it doesn't, but you get the whole idea. If I'm only spending 3 hours a week, I already know what grade I'm probably going to get, right? So this starts to get in the idea of probability, it gets in the idea of how I behave, and now I can use the data to sort of predict how I should be behaving, right? Pretty cool, right? I mean, I think it's cool, because now you have a whole sort of idea in your mind. Let's say I have a limitation. Let's say I have a job in the evening. I got to go to work. I don't have those hours, right? I already know there's going to be a problem getting grades. So the whole cycle of your brain and our mind and learning and data is all very interesting based around what can be done with what we have, what resources are available to us. Okay, so which line best fits or approximates the data? Go back through slope. Remember, this line goes up to the right. So up to right. I think I did this with you last semester, right? Okay, you're sitting there. Raise your arm out to the side. Raise your arm up to the right. Raise your arm up to the right. Where are you guys? Raise your arm up to the right. Okay, and say up to the right. Positive slope. You with me? Okay, and yeah, that was kind of funny the last time we did that, and I'm remembering it now. Positive slope. Okay, that's a positive slope, and therefore a positive relationship. there's an interesting word, right? Relationship. And it's always funny in a math class when we talk about relationships. Don't you think that's funny? Right? Think of relationships. Think of a word that has so many different meanings, right? Anybody have a pet? Do you consider your time with your pet a relationship? I do. I have cats at home. I kind of consider I have a relationship with pets, right? I see some of you are like rolling your eyes, right? Because you're thinking of maybe different. You have parents? Do you have a relationship with your parents? Right? What about a significant other? You have a relationship with a significant other potentially, right? And that could be, who knows what all this is, right? For each individual person, this can be a wide variability of what that even means, right? Okay, in math, you're talking about a positive relationship being the angle of the line up to the right, okay, for this context. And positive being the more you study, the better grade you get. Fair enough? In positive relationship in this context, what it is for this? Okay. And I want to emphasize that because I love my next example, or maybe I don't love it. Age of men. Age of men. And remaining hair on their head. Man, this is tough. Okay, remaining hair on head. Okay, here's our next example. All right, so I'm trying to get your attention, I guess, right? Age of men, low, right? Younger, older. You with me? And we don't even need the details. We don't need it right now to get across the point, right? Age of men. They're aging as we move to the right, okay? And then hair on their head. This being not much, this being more. The more hair on their head is the higher up the scale, right? That makes sense intuitively. That's the way it is, right? Well, what does this data look like? This data looks like younger, more hair. You with me? You see where we're going with this? Okay, so there's other data, and the data starts to fill in. Okay, you see where we're headed here.
Good morning, my mules. I'm Timon.
And I'm Maddie, and we're here with your morning announcement.
Attention, mighty mules. February is Black History Month. Langston Hughes was a poet, social activist, novelist, playwright, and columnist for the Joplin, Missouri. From Joplin,
Should have started this earlier.
Hughes is best recognized as the leader of the Harlem Renaissance
I don't have a pause on there to like pause and then restart where it's 1 file.
He earned his BA from Lincoln University. Hughes said, "Hold fast the dream, for if dreams die, life is a broken wing bird that cannot fly."
Well, I just want to point out this, right? A negative relationship. That's the only thing I want to get to before I end this, all right? A negative relationship. The more this increases, the more this decreases. And this is down to the right. This is a negative slope, okay? Good.